Chapter 2, Video 3. Today we're going to talk about the EKG wave complexes and what each component of the EKG strip represents. That's very important, and I think the things that we discussed in the previous lectures will make sense to you, knowing what exactly it is you're looking at. The first thing that I want you guys to do is be able to define what an EKG is. So the EKG is a recording of the heart's electrical activity. So that's very important to know. Here is a list of what each thing on the EKG strip represents. So if you go back to the EKG strip, this is your P wave, this is your QRS complex, and then we get into the ST segment, and this is your T wave. So as we talk about each component, you'll know exactly. You can flip back and forth to one of these pictures and look at it and know exactly what you're looking at. So the P wave represents atrial depolarization, okay? A normal P is small, rounded, and upright. Atrial depolarization must occur for atrial contraction to happen. So that electrical activity happens, and then that contraction follows right behind. So one thing we need to look at, we need to know what the normal looks like and know that there's things that can alter. There's things that can alter the normal. So if there's something going on in the atrium, then that P wave could become altered, which we'll talk about later as we move forward. The TA wave is atrial repolarization, the TA. And notice you don't see a TA wave written across here. And I'm going to explain that to you shortly. But the TA wave represents atrial depolarization, and it's not usually seen because it happens simultaneously with the QRS. So that atrial relaxation, that atrial repolarization, those atriums are actually resting while the QRS complex, while the ventricles are beating. So it's happening at the same time of this QRS, so that's why you do not see that TA wave. Now we're going to talk about the QRS complex. The QRS complex represents ventricular depolarization. The normal QRS is spiked in appearance, consisting of one or more deflecting from the baseline. The QRS is the most easily identified thing on the EKG strip. However, again, our shapes may vary. Now we're going to talk about the T wave, not the TA. Notice this does not have a TA on the end, so be careful with that when you're answering test questions. The T wave represents ventricular repolarization. The normal T wave is broad and rounded. If the QRS is upright, the T wave is usually upright also. If there is a QRS, there must be a T wave. Any tissue that depolarizes must repolarize. So if you have a QRS, you're going to have a T wave because that T wave is representing that rest, that repolarization. And then we have a U wave. The U wave is late ventricular repolarization. It's not normally seen, but it can be seen. If the U wave is present, it's going to follow that T wave. It should be shallow and rounded, the same deflection as the T wave. If the T wave is upright, the U wave should also be upright, if there is one present, if you see the U wave. All right, so this is an EKG strip. This is what we're looking at. Each P, QRS, and T wave, that represents a sequence. That represents one heartbeat. So this segment from the P wave all the way to the T wave represents one heartbeat. The PR segment, we can see here, this breaks it down for you. This is the PR segment. The PR segment is the flat line between the P wave and the QRS, and between the QRS and the T, okay? This flat line indicates electrical silence, okay? But this is your PR segment, and this is your ST segment, because we have our QRS. So it starts with the S and ends with the beginning of the T. So this flat line between that S and that T is the ST segment. But the actual QRS complex, this is the QRS complex, but this is the Q, this is the R, and then this is the S. This kind of shows you guys how the electricity travels through the myocardium. Atrial contraction is going to occur in the P wave and the PR segment. Ventricular contraction occurs in the QRS and the ST segment. When the atria depolarizes, the P wave is written on the EKG paper, and when the ventricles depolarize, that QRS is written on the EKG paper. So this kind of shows you the path. Each PQRS segment, again, PQRST segment represents one heartbeat. The PR segment is the flat line between the P wave and the QRS. The ST segment is the flat line between the QRS complex and the T wave. And the ST segment is at the isoelectric line. That's that baseline. So when we talk about that isoelectric line, we're thinking about that baseline. The baseline is the flat line between the T wave of one beat and the P wave of the next beat. It's also called the isoelectric line. Atrial contraction occurs during the P wave and the PR segment. Ventricular contraction occurs during the QRS and the ST segment. We went over that just a few moments ago. We're going to go down. I'm going to pull a couple of strips. Don't worry about the rhythms right now. Just trying to figure out what it is you're looking at. So when you look at this strip, this is actually the QRS complex. So this is your QRS complex. And this is actually your T wave, okay? So don't get that confused. When you get to this strip, we have a P wave, then we have a QRS and a T, and then we have a P, but we don't have QRS that's following, so we know those ventricles aren't putting out, but these are P waves, so that tells us that the atrium is still trying to contract and work. Alright, this is a P, this is a QRS complex, and this is the T wave. We got the QRS complex, and then we have the T wave dipping down here. This is the T wave. So we have the QRS, and then we have the T wave. That's all for this video. I will be posting another video. If you have questions, please let me know.